So we have been raised all in schools, hopefully, and at some point or another, we have come across a table and have come across multiplication tables and charts. So I'm just going to start this presentation by asking you a little cheesy joke, a little question. So why did the boy do multiplication on the floor? Anybody? Well, because his teacher told him not to use tables. Ha ha ha. Okay. All right.
Haha, there you
Haha.
go.
Well, my name is Andrew Brown, and I will be showing everybody how to make a table reflecting the patterns and relationships that suggest how a particular problem can be solved. So the question is, what is make a table? Well, make a table is a way to reflect the data that you have within a word problem. Well, these tables that students make can reveal patterns and relationships that offer suggestions towards the steps needed to take to solve the problem. One example is this kind of chart. Well, you see that we have 4 swimmers with a certain amount of meters they swam. Well, the thing is that with these 4 swimmers, can you predict the outcome for swimmer 4 if swimmer 1 swam 500 meters and each swimmer below him swam 75 meters less? Well, swimmer 4 swam 275 meters. That's just one example of a table. Another table, like I've said previously, is this giant thing. Everyone has seen it. You can easily use this for any kind of multiplication problem, to solve any kind of math homework problem, or to help you with a problem strategy. But in all conclusion, I hope that each of you have a better understanding, or I have refreshed your mind in how simple and easy it is to use the problem-solving strategy of making a table for all ages. So I'm just going to pass it over to Miss Micah, and she will be talking to you about Pascal's triangle.
And I'm just going to say thank you, Alexis and Andrew, for your insight into mathematical patterns. And my name is Micah Maddie, and I am going to share with you a little bit about Pascal's triangle today. I can get it on the right slide here. Okay, so we're covering Pascal's triangle. And what is Pascal's triangle? It is, as our book states, one of the most interesting and useful patterns in all of mathematics. It is a numerical array used to solve easier, similar problems, and it was named after Blaise Pascal, but the triangle was known in China in 1303, which was way before Pascal was even born. So I don't know why it was named after him. But I'm going to show you just a simple example, and the book gives us a more elaborate explanation, but I'm going to keep it pretty simple. If you want to look into that, it's on pages 24 through 27. I obtained this example through mathisfun.com, which is probably Benzie's favorite website because she thinks math is fun, but I do not. So anyways, I kept it pretty easy with a basic example. So you're welcome. This is the basic version of Pascal's triangle. First, we need to identify that there is a diagonal pattern. It's most simple to identify because the first diagonal column is going to be just ones. As you see on the far left, it goes straight down. It's all ones. The next diagonal column is going to be your counting numbers. 1, 2, 3, 4, 5, 6, 7. And the third column is going to be triangular numbers. And I didn't know how to find these at first because I didn't know what triangular numbers even meant until I found this website, mathisfun.com. And they gave this little diagram. It's a dot sequence that shows exactly how to find the triangular number pattern. And it works when you have smaller numbers, but when you get into the larger numbers, you would have 1,000 dots all over your page, and I don't think it would be very practical then. But just for the smaller numbers, there it is. So the fourth column is going to be the tetrahedrals. I always say that wrong. So you can see that the diagonal patterns are pretty easy to identify in the Pascal triangle. So this is still the same triangle that we had used before, and this one has a symmetrical pattern as well as diagonal, and the numbers on the left directly mirror the numbers on the right, which it helped me that they had a line down the middle because it was kind of hard for me to see until that line of symmetry was drawn. And then this pattern, this next one, shows that these double in each time in powers of 2. So 1 is obviously 1, but 1 plus 1 is 2, and then you just do the powers of 2. So 2 squared is 4, 4 squared is 8, 8 squared is 16, so on and so forth. And then we're not going to get too much into depth because I am running out of time, but you can see that this one goes by powers of 11, which I would have never found that out on my own, but it seems pretty simple now that it's stated right there. They all go by powers of 11. And then this one shows some patterns of squares. So as you can see, the Pascal's triangle, they make word problems so much easier. Like the homework problems that we had last weekend, if I had plugged those numbers into the Pascal triangle, I would have been able to find the patterns way easier. And so today we covered several different ways of finding and figuring out mathematical problems using finding the pattern, using tables, and using Pascal's triangle. It makes your lives so much easier. So thank you, and I'll see you next week.